First thing I'm going to do is going to look at this, okay, and I'm going to go, okay, the formula I'm going to use is obviously going to use the sine version. See the one I'm underlined in blue? That's the one I'm using. See the way it's 2x? I'm going to call it 2x over 1. That means my a value is 1. And anywhere there used to be an x, there's now a 2x. Is that okay? So here's what we're going to do. We're going to follow our formula strictly, okay? It's going to be 1 divided by the square root. Now, what's a squared again? 1 squared. What's x squared? Instead of x squared, we have 2x, 2b squared, yeah? Now, there is one little part here that you're going to have to remember that's not in your tables. You differentiate what's in that part. So, since there's a 2x, what happens when I differentiate 2x? There's a 2. There's a missing part. Is that right? And my answer will look something like this. 1 over the square root of 1 minus, what's 2x to be squared? 4x squared, and then multiply that by 2. Now, there is in this question, it does actually ask me to replace x with 0. So I'll do that now. What am I going to replace x with 0? It's going to be 1 over root 1 multiplied by, and the answer is 2. Is that right? Now, will you guys try part 3 for me? Part 3, and you're going to use cos, okay? And once again, you're going to put your a value equal to 1. And I shall take the roll. You're using a equals 1, and you're using the formula underlined in red. Okay, let's find out. Okay, so is everybody agreed that it's 3x over 1? Everybody agreed with 3x over 1? Everybody happy with saying that a equals 1? And instead of x, it's going to be 3x. All right? No. Minus 1 over the square root of 1 squared minus 3x to be squared. It's the formula. Instead of having an x here, you have a 3x. So it's 3x instead of x. Did you differentiate the 3x to get? Everybody get that? Okay. I think you're right about the error though. See the way it's cos inverse 3x. It's not cos inverse x. It's cos inverse 3x. So this formula is designed for cos inverse x. It's not designed for cos inverse 3x. So anywhere you see an x, you replace it with 3x. Yes. 3 on top. Yeah, you can't in this case. Yeah. There's a reason I chose this way a couple of years back. It's a one method fits everything situation. Everybody happy with that? Now, when x is 6, that's going to be a negative number all day long, and you're going to get mad error, aren't you? Anybody else get mad error? Yeah, that's it. It's mad error. Nothing you can do about it. Because when you put 6 squared in there, it's going to be a negative number, and there's nothing you can do about it. It's a mad error. Well, yeah, infinity not defined. You name it, just not defined. I don't know. I'm surprised. Some books do make glitches. Okay. It's the same deal. Once you know how to put it in, you progress. Shouldn't be. Usually you get a clean answer. Okay, lads. You ready? Okay. Once again, A always equals 1. Everybody agreed? Now, this one here I'm going to turn into, so this for part 1. I've done it in video, but look, we've done it before, but we'll do it again. Right, this one's a really awkward one, and I'll show you why. I'm going to turn this into sine inverse 3 over x divided by 1. Does everybody see that? What could I turn 3 over x into? What power would that be? 3x. Yeah, I think that looks a bit nicer, doesn't it? Now, do you see the way my a value is still 1? Everybody happy the a value is still 1? Okay. Here they are here. Which one am I using? I'm using this first one. Now, Ken, you notice that instead of X, what do we have this time? Instead of X, what do we have? Exactly. Anywhere you see X, you're going to replace it with. Okay, that's exactly what we're going to have to do. So we go f dash X is 1 all over A squared, which is, what's it? 1 squared, yeah? Yes. Oh, sorry. Sorry, 3x minus 1. Thanks for that. It's 3x minus 1. Thanks. Sorry about that. Do you see 1 over x is x to the power minus 1. So 3 over x would be 3x minus 1. Thanks for that. Now, we're going to replace the x squared with, we're going to replace the x squared with 3x minus 1. Now, what's the missing part that's not in your notes? Differentiate it. So we're going to have to, give it a second. Oh, it is. Yeah, yeah. I just kind of waiting on my gone apparatus not to be so faulty. It's taken. There we go. All right, guys, that's a squared there. Now, lads, I'm going to differentiate 3x minus 1. What happens when you differentiate? Bring the 1 to the front. And then x minus. Yeah. Now, we're nearly there. Very close to being done. Okay, what do we have here now? 1 over the square root of. Anybody? 1 minus. What's 3 times 3? What's x minus 1 squared? I say some music confused here. This 2 works 3 to turn into 9, and the 2 works from that to turn into x minus 2. 9 is 3 times 3. 3 squared is 9. And then we have to have on the over here is what the minus. Yeah. Now that's, you can leave it like that. That's completely right. Like sometimes the book might ask you to mess around with it and change it into a different form. So it might ask you like 3x minus 2, and then it might ask what it might ask you to do. Actually, show you what it's going. It'll actually be worth doing it, believe it or not. So look at this, okay? Does everybody see 1 minus 9x minus 2? Does everybody see that part there? Everybody sees it? Look what I'm going to do with it. You ready? Here's what I'm going to do with it. I'm going to change the 9x minus 2 into what? 9 over x squared. You feel that? I'm going to give it a common denominator. What do we do there? X squared over. Is what I have in blue, is that still exactly the same as that? Bar the square root sign. It is. Okay. Here's what we're going to do next, okay? I'm going to turn this into x squared minus 9 all over x squared. You feel with that? I'm going to square root the full thing. Why am I square rooting the full thing? It was in square root to begin with, wasn't it? Okay. Now, I can't square root the top. Just going to leave the square root alone here. See that x squared minus 9? I can't touch that. Somebody said the difference of two squares, which is fair enough. I can turn it into that. But notice that it's not the same bracket twice. So I'm not going to get any further than that. Is that okay? Now, what happens to the bottom bracket then? What happens to the square root of x squared on the bottom? Just x, isn't it? Now, look up here. What can I do with this part here? Minus 3 over x squared. Do you see that x on the bottom? What does it cancel with? That's your answer. Minus 3 over x times root x squared minus 9. You'll need to see that again in slow-mo. Okay? You need to go through it again on your own. Okay? Absolutely. Now, it depends on how it's presented. Yeah. If they ask you to present it slightly differently, you might have to. Okay? Once again, in a lot of cases with a question like that, you're just in there to get your 7 out of 10 and make a good pass. Okay. Now, let's look at this one here, part 3. Everybody see part 3? Which one am I using? Yeah. Would everybody be all right if I wrote it like this? Cos x over 2 divided by 1. That makes sense. And that sticks rigidly to my rule of a equals 1. Now, it would actually work if you just said a equals 2 for this one and slot it in 2. You know what I was concerned about? I was concerned about people making the wrong choice with other questions. So that's why I devised this one method does all. Okay. So this will, if you use a equals 1 and do that trick, you'll never ever go wrong. You don't even have to think about the question. If you start subbing in different a values, you're going to go wrong. Just from experience. Okay. So here's what we're going to do. We're going to say a equals 1, and instead of x, what do we have instead of x? X over 2. Is that right? So let's do the cos formula. What's the cos formula? Minus 1 over 1 squared, yeah, and then plus x over 2 squared, yeah, and then differentiate this. Differentiate a half x. If I was differentiating 5x, the answer would be 5. If I'm differentiating a half x, the answer is half. And you're very much allowed. So once again, I do a bit of exploring on this one, if I'm being honest. I would actually go that little bit further. You haven't made a mistake. But here's what I'm doing. I'm taking this part here. Oh, why do I keep doing that? So give me a sec. Remind me not to press the highlighter button anytime again. Just thanks. Can't get over how slow it is. Now, do you see this here? Have you see that? I'm going to turn that into 1 plus x squared over 4. And then I'm going to turn that into 4 over 4. Have you see that? Then I'm going to turn that into 4 plus x squared all over. And then when I square root it, I'm going to square root top and bottom. Square root the top, leave it the same. Square root the bottom, turns into. What happens there then? And the answer is minus 1 over 4 plus squared. Go with that. Now, I am well aware that if you just made a2, what's this for, cos or sine? Cos. Why is it? It should be a minus, shouldn't it? It doesn't affect anything. Just minus. Instead of that, that's minus. Instead of that, that's a minus. And instead of that, it's a minus. So it's 4 minus x squared then, yeah? But if you just did a equals 2 for this, you get a2 squared, which is 4. You get the same answer, no bother. So if the a value is a regular number, you can just say that a is 2 or a is 4 or a is 5. But for everything else that's not a regular number, you always set the a value equal to 1. All right. Okay, finally. You're going to be asked to do product and sign rules using these. You get what I'm saying? So you're going to be asked to use like u is 2x. What's the u dx then? 2. V is what? Tan inverse x. And what's the v dx using your tables? Is it not a is 1? So it's not 1 over 1 squared plus x squared, which is simply 1 over 1 plus x squared. You go with that. And then finally, you're going to do the product rule. What's the product rule? U times the v dx. V times the u dx. Times what's the 2x? So that'd be 2x tan inverse x. You see that these answers are quite weird. They don't, they're really like, they're really like long, ugly answers. And you would think you'd have to do extra work on that, but you don't. Just question 5, part 2. Okay, I can't get